In Algebra 1, Section 3.1, we're dealing with graphing relationships. So basically, we're going to be comparing two sets of data and seeing how they relate to each other. So the first question says that each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves. Eventually, there are no more leaves in the tree. Okay? So it's asking us which one of these best represents the leaves falling over time. So the two sets of data we're comparing is time and leaves. Because leaves are continuously falling, and it's not growing or it's not like there's a certain amount of leaves that is done in a day, fall in a day, they're just continuously falling. These kind of graphs are what they call continuous graphs, because it's continually decreasing, increasing, staying still. So these are saying that there's growth that's happening when it goes up. That means more leaves are growing. This one, these are saying the leaves are decreasing. And this one right here is stating that the leaves are staying still. Okay? There's none leaves growing and there's none leaves falling. They're just standing there. So, because we're dealing with leaves, this one says it's growth. So since none of it's not saying at all that the leaves are growing. It just says each day that they're falling. So we know that it cannot be C. I did A, B, C. My apologies. But, so it has to be between these ones. Now, because this one says that the leaves are not falling or growing here, because it has that, we know it can't be that either. Because it doesn't say that the leaves anytime stop. It says that they continuously fall. So each day, several leaves fall from the tree. So it can't be that. So on B, it should be this one. It's saying here that the leaves are falling. Okay, it's falling, falling. All of a sudden here, there's a gust of wind. So it falls a little bit more drastically. And then it continuously fall until there's none left. Right? Eventually there are no more leaves. So it has to be B. Is what illustrates. And again, this is called a continuous graph. Number 2, it says a small bookstore sold between 5 and 8 books a day. So please make sure that when you are graphing, you label. So this is the days that are occurring. 1, 2, 3, 4, 5, 6, 7. Okay? And these are the books. Books sold. 1, 2, 3, 4, 5. Oh, sorry. 2, 4, 6, 8. Okay? So, somewhere in between here, between 5 and 8, books are being sold. But it's a certain amount of books that are sold a day. So it's not like books are continuously being sold. It's this day, this many. So this is what we call a discrete graph. Miss P might have spelled that wrong. Check discrete in your book. Okay? So here we're going to go, the first day they could have sold 8 books. Good day. The second day they could have sold 5 books, the next day they could have sold 6, and the next day 8, next day 5, then 5, and then 7. Okay? This is what they call discrete. It's like a scatter plot. It's just distinct points that there's really no relationship between them. As the days go on, a certain amount of books are sold each day. So again, this is continuous, this is discrete. Go ahead and try page 167, numbers 3 to 6, 167, numbers 3 to 6, and I will see you in class.